Set it equal to 0, and factor is another one that we love. So, and then each factor you set equal to 0. These are the rules of solving that save lives. Dun dun dun. So now the first one, this one is one where if you wanted to factor and go about setting equal to 0, it could be done, but this one's actually a little easier. If you can get it to a single trig function by itself, then you go with it. So for this first one, minus 6 sine x and minus 6 sine x from both sides. These are like terms, and so you can combine them. Like 8 sines, take away 6 of them, leaves you with 2 sine x's, and equal to negative 1. The idea is isolate the sine of x. I don't want that 2 in front of there. I have to divide both sides by 2. And once you get to here, you're going to find that when I ask for exact answers, that same alarm goes off. It says unit circle is involved and radicals stay. So that's where we're at. Sine of x equals negative 1/2. You are not going to go to your calculator and do inverse sine of negative 1/2. No, no, no. You're going to draw a little circle and say, hey, where on there is sine negative 1/2? And that is 2 places. When do you have a height of negative 1/2? This angle and this angle. Now I drew a little vertical line in there because I'm thinking the sine is that y-coordinate. You just have to come up with the angles that go with it. Those, if you remember, are pi over 6 angles. They're pi over 6 after the pi, and there's pi over 6 down from 2 pi. So you have to remember 6 pi over 6. Yeah, I know. Sorry, I'm going to make that go away. Go away. Go away. There we go. Sine of, this is 6 pi over 6 at 2 pi, or at pi, I'm sorry. So this is 7 pi over 6. And then 2 pi is like 12 pi over 6, so this is 11 pi over 6. So those end up being our two solutions, and it says exact solutions 0 to 360, so it actually wants solutions. Guys, please quiet. That 0 to 360 means anywhere in that first trip around the circle, but it also wants them in degrees, and you guys can handle that. That's 180 plus 30, so 220. Not a big deal. And 360 minus 30, so that's 330. Those end up being our two, is that right? 180 plus 30? 210. There we go. 330, there we go. 210 and 330. Those are solutions. Now when I go to Desmos and do this, we did this earlier when we graphed both sides of the equation. We would graph like 8 sine x. Do you remember when we did that last week maybe? And then 6 sine x minus 1. What we found out is where things are equal is where they collide. And these functions collide all over the place. However, what you remember is it has bounds. It said somewhere between 0 and 360. You grow x equals 0. And this, by the way, Desmos does radians all the time, so I'm going to put 2 pi instead of 360. So 2 pi. Those vertical lines are there to say, only give me the solutions. That means only tell me where they collide between those two vertical lines. And they meet 2 places. And look, I hover. Hey, 7 pi over 6. It's all about the x value. And 11 pi over 6. Same thing. You can check these solutions all you want. If you go off into the world and forevermore, whenever you see an equation, you want to just graph each side and see where they meet because you have a calculator in front of you or a Desmos is with you for the rest of your life, great. If that helps you resolve the issue, go for it. But algebraically, what you end up doing are following these little 3 steps. Isolate a trig function and or set it equal to 0 and factor and set factor equal to 0. It's weird how that emphasis is on there. Okay. So here's the next option. If you can't get like a sine or a tangent or a cosine by itself, you get it all equal to 0 in your factor. I want you to hear a huge warning. Some of you are going to do this right away. Like I'm telling you, don't do this and you're going to do it. Do not cancel trig functions when you're solving. We only do it when we're simplifying. Weird, huh? Do not cancel a trig function when solving. Because when you do, some of your solutions disappear with it. Whoa. It wipes them off the planet. You do not want that. Do not cancel the trig func whilst solving. Is that a good use of whilst?
Yeah.
I like it. It sounds great. Then we go to that plan B, which is get it equal to 0. Subtract tan x from both sides. Let's roll. Come on. Tan x minus tan x. And that means we get tan x sine squared x minus tan x equal to 0. And once it's equal to 0, you look for a common thing you can factor out, like a tangent. I see a tan. So you pull it out. And you get sine squared x minus 1 equal to 0. Now, PIDDARs are going off like crazy. I hear them. Get those under control. That right there, it is a PID, but it's not the one you think. You think it's cosine squared? Almost. It's actually reversed, which means it's negative cosine squared. So just a little information for you. I'm going to run over here where I have some more room. Sorry, I'm going to run this way because I need more space. But what happens is, just a little thought, y'all know cosine squared x is 1 minus sine squared. Well, if you factor a negative out, basically multiply both sides by negative, you change the negative sine squared to positive and the negative 1, or the positive 1 to negative 1, which is what we're seeing right now. It just changes the sign of each term. So we do have an identity with that. It's just going to be a different one than maybe you thought. So we have tangent x that we factored out, and it turns out that thing in parentheses is actually just, what, negative cosine squared? Isn't it all equal to 0? Well, this is all we need, because those factors are the pieces that we set equal to 0 now. So we go, for each factor, you take tangent of x, set it equal to 0. Negative, now this is cosine of x squared equal to 0. Turns out two things don't matter. That negative doesn't matter. You'll still be 0. That squared won't matter when it's equal to 0. So in the end, it's just cosine. You could square root both sides and divide by negative 1, and 0 is just going to still be 0. So that's important. Those two things are solved by looking at a unit circle. So you go, hey, when's tangent equal to 0? Well, you know it's at 0 and pi and 2 pi. However, you're only supposed to write answers from 0 to 2 pi. And guess what? It says right here, very, very subtly, not including 2 pi. So you're going to go 0 and pi are your solutions for x. Isn't that kind of cool? Dun, dun, dun. Let's circle it in purple. That's one part. Oh, but there's more. Cosine of x equals 0. Where does that happen? So you go to cosine is x. When is it 0? Well, it only happens when you don't move left or right, which is at the poles, pi over 2 and 3 pi over 2. So your solutions there are pi over 2 and 3 pi over 2. There are 4 solutions. If I go to Demomo and I graph that original function, they hit at 0, pi, pi over 2, and 3 pi over 2 in the interval 0 to 2 pi. They collide that many times. 4 different intersections. That's okay. Normal. Okay, but your job is factor it when it's equal to 0, and then set each factor equal to 0. It gets better. You do it a lot. Hey, we get to look at this one. Hey, it's already factored.
Wow. That's good news.
Find all the solutions, though. And all solutions, it is good news, means whatever x you get, you are going to add plus or minus 2k pi. And that means all solutions mean all the things you could get from going around the unit circle. K is a whole number multiplier. So it's just saying, give me some pi's. That's what that means. So we're going to go around the circle as many times as forward and backward and land on similar places. Just get your solutions and add plus or minus 2k pi. It takes care of business. There are more nuanced ways we can look at it, and I'll mention those, but in general, hey, so I'll set each factor Factors mean they're multiplied together, and these are definitely multiplied. Set each factor equal to 0. Hey, we've done this before. Go to unit circle. Hey, when's cosine equal to 0? Oh, pi over 2 and 3 pi over 2. So that's the idea. The only thing is you add to it plus or minus 2k pi. Now, some of you are real savvy and realize, hey, couldn't I just add pi over and over again and get those numbers? And you could. You could actually write plus or minus k pi. That would be cool. It would be what I would say a little more elegant, but not necessary. So I'm going to say, if you want to keep it simple, you just take your answers and add plus or minus 2k pi. If you recognize that actually all those are actually just a pi apart, there we go, 2k pi, then you're good to go. Sine of x is 0. You know where that happens, right? Sine is height. It happens at these places, 0 and pi. So if I said x equals 0 and x equals pi, those are great. But you also want to go in there plus or minus 2k pi. Got it? Plus or minus 2k pi. If you're feeling like, hey, aren't those also pi apart? Could I just say 0 plus or minus k pi because all of these are pi apart? Sure. Again, very elegant, but it does the job to leave it like it is. You don't need to. We like elegant sometimes. Now, the bottom. Find all exact solutions from 0 to 360. It's equal to 0. Is it equal to 0? Check. Is it factored? Not yet. Pull out what they have in common. They both have a cosine. Divide it out and you get 2 cos plus 1 equal to 0. There it is. Now it's factored. Check. Set the factors equal to 0. I'm going to do that now. Exactly. So cosine of x equals 0. A lot of repeats. This one's the nuanced one. If I have 2 cosine of x plus 1, you set that equal to 0 too. But you got to do a little work. Subtract 1. You got to isolate the trig function. So subtract 1, subtract 1. Got to get it alone. Divide by 2. That stuff. That's an isolated trig function. You're ready to draw a picture and say, when is the cosine equal to 0? Oh, we know that one's pi over 2 and 3 pi over 2. Got it. Now this is in degrees, so I'm going to put 90 and 270. Same meaning. And it says only the answer is 0 to 360, so I can just list those two. When is cosine negative a half, though? It'd be like left a half. Here we go. 120, because I know that one's 120 right here. And then the other one that's down 60 from 180, or back 30 from 270, that'd be 240. So it's x is 120 and x is 240. Definitely dependent on the unit circle for those values. 4 solutions from 0 to 360. All of them count. Now, I think that's plenty. Because I think tomorrow it's more of the same. It's just getting it equal to 0, factoring it, using identities. No, it just adds to the fun. Mo fun. I think we'll give Grace at least one more view of everyone. Want to say hi before I put it away?
Hi, Grace.
Oh, here she is. Okay, that's excellent. Off we go.